Hey folks, today we have a question from Shazaib. I apologize if I pronounced that incorrectly. How many grams of barium sulfate form when 35 milliliters of 0.160 molar barium chloride reacts with 58 milliliters of 0.065 molar sodium sulfate? Okay, there's a lot to cover with this question, so I'm going to go pretty fast. If you have any questions, contact me. But let's get started. The first step is to get the balanced reaction out. So we have barium chloride here. So barium is Ba. Its oxidation number is +2. Chlorines oxidation number is -1. So this needs to be BaCl2. This is going to be reacting with sodium sulfate. Sodium oxidation number is +1. Sulfate is -2. SO4 is -2. So this is going to need to be Na2SO4. Right? Now this is going to end up forming, this is a double replacement reaction. So essentially we're just swapping out the barium and the sodium here. So we're going to end up with barium sulfate. Both barium and sulfate are +2 and -2, so they do not need any additional subscript numbers there. So this is just going to be BaSO4, again, +2, -2 here, plus sodium chloride, again, 1 to 1, +1, -1 there. So they do not need any subscript numbers. And if you look here, we are nearly balanced just off the bat there, but we have Na2 here and only Na, and we have Cl2 here and only Cl. So we are going to make this 2 NaCl. Ta-da! We're balanced. All right, let's get these amounts in there. We have 35 milliliters, so 0.035 liters. You convert to liters. Careful. And we have 58 milliliters. Is that correct? Yes, 58 milliliters. 0.058 liters here. And we have 0.160 molar here. And we have 0.065 molar here. And the reason why we put these down is we want to find the number of moles. Moles is equal to molarity times volume. So all we need to do is multiply these numbers together to find the number of moles. So we go 0.035 times 0.160. We have 0.0056 moles here. And we have 0.058 times 0.065. We have 0.00377 moles. 0.00377 moles here. Now you might be asking, why are we finding the moles? Well, we need to find the limiting reagent to this problem here. The limiting reagent is going to be this guy here because it is a smaller amount and this is a 1-to-1 ratio. Because that is a limiting reagent, the number of moles of BaSO4 is determined by that number of moles there. That is also a 1-to-1 ratio. So we end up with having 0.00377 moles of BaSO4. Now the question did not ask for moles. The question asked for grams. To convert moles to grams, we're going to have to find the molar mass of BaSO4. I am going to be rounding here. I'm going to be rounding quite a lot. BaSO4 is 137. Well, Ba is 137 plus sulfur, which is 32, plus 4 oxygens, which is going to be 4 times 16. Again, I am rounding quite a lot here. You should redo this question with however much accuracy and precision that your teacher requires. 233 grams per mole. Oh yeah, easy. Final step now is just to multiply this number of moles by this molar mass. So we end up with 0.00377 times 233. 0.00377 times 233, and that's a 0.878, rounding to 3 significant figures, 878 grams of BaSO4. All right, I hope that has helped. And again, if you have any questions, reach out to me. Sorry it went so fast. I have to fit in the time limit. See ya.